Hello my dear viewers, this is your teacher again, Science Bro. I'm here again. I've brought for you a video in organic chemistry. Now, today I'm going to discuss what we call nomenclature or naming organic compounds. Giving names to compounds is actually important in identification of those compounds. But before I start, I request that you hit the subscribe button. If you have never subscribed, please just help me and do that. Below the video, click on the subscribe button. Then sit and watch this video to the end. I'm breaking down how we name organic compounds. So by the end of the video, you must be able to name any organic compound before you. Now, before we name organic compounds, we should notice that the IUPAC is a body that is concerned with naming organic compounds, giving rules for naming organic compounds. In fact, the IUPAC, which is called the International Union of Pure and Applied Chemistry, that body was instituted to help us to set standards in chemistry, such as naming compounds, setting standards for symbols, setting standards for atomic weights, and also giving rewards in chemistry. Now, before the IUPAC, compounds were named using common names, or we call them trivial names. Those names they were based on the origin of the compound and sometimes the reactivity of the compound, sometimes the inventors or the people who discovered the compound. For example, formic acid was named after the name called an ant because it came from ants. So the Latin word for ants was called formica. That's why they baptized that acid formic acid, which we call methanoic acid. Some other trivial names and common names have been kept on because some of them are, in fact, we can't do without them because some systematic IUPAC names are very long. So by cutting short, we use the trivial names, and some of them are acceptable. Like in alkanes, we have methane, ethane, which have been kept on, though they were common names. So names like N-butane were actually common names, but IUPAC gave it like butane. So a few changes were made, some significant changes. Now the IUPAC gives us a systematic way of naming organic compounds. But before we dive into some examples, there are some basics that we need to know. We need to know the knowledge of functional groups. We need to know the knowledge of what we call suffixes, and we need some knowledge of what we call the homologous series. Now, I've arranged this table based on what we call a priority of those functional groups. That in case you have more than one functional group, which functional group do you give priority? Now, like here, the first homologous series or the first class of compounds is the carboxylic acids here. I've omitted certain groups for simplicity of this video and easy understanding of naming. So this does not include all the functional groups, only some important ones have been included here. So a carboxylic acid, when it's appearing, this carboxyl group in the formula, when it appears with some other group like the OH group here, then priority will be given to the carboxyl group here. So we base on this priority table to keep choice of where to number the longest carbon chain from. Now, we have the carboxylic acids here, the first to be ranked, and we are going to use this as the representative formulas, then we shall use this as the principal names. So if a chain has this group called COOH or the carboxyl group, then it will be called alkanoic acid. Anester will be called alkanoate. So we just attach here what I'm going to call the root word here. So there are root words here that I'm going to attach here in generating a full name. For example, I can attach eth here and call it ethanoic acid. I can attach prop, call it propanoic acid. So these are going to be my parent names, which I'm going to attach the relevant or suitable root words to come up with the actual name that I want for the compound. So they have suffixes. These suffixes are going to be placed at the end of the name, and we are going to see how we put in these suffixes. Now, in case some of these functional groups here are not actually, they are acting as branches on the chain, then they will be named with these other names where we are calling them the substituents. So if we have this amino group as a branch on the chain, we shall call it amino. But if the amine is making the parent name, we shall call it alkanamide. So that's how we are going to use our table. We shall be referring it here as we move on. Now, also in naming organic compounds, we need to know what we call the IUPAC rules. So IUPAC rules, I've summarized them here. Of course, you can find in several textbooks where they have really given a detailed outline, but being that I'm working on a small surface, so I've summarized some few important ones for you. The first one, we identify the longest carbon chain, which we call the parent chain, and it will give us the parent name. And the parent name will actually be from these principal names here. Then we shall number the carbon atoms in such a way that we shall be looking at the branches, and the branches or the substituents should be numbered such that they receive the lowest locants. The digits we are going to attach on them, we are calling them the locant. Then for similar substituents or branches, we shall be attaching prefixes here. A prefix is a word before the main word or before the root word. Then a suffix comes after the root word. For different substituents, we shall follow alphabets. Then this rule is also important for different substituents in equivalent positions. Equivalent positions, we mean if you number from left to right and realize that two substituents, one is at position 3 and 5, one is at position 3, one is at 5, then on numbering again from the other side, again it maintains 5 and 3, then we shall give the lowest number to the substituent we are going to name first. So these are the basics. So let's dive into examples. I'm going to move in such a way that I'll look at alkanes, alkenes separately until I reach amines. Then we shall combine a mixture of functional groups and finally summarize. So let's start. How do we come up with the names in case it's an alkane? So all alkanes, we just attach their suffixes ane. The suffix for alkanes is ane here. So the first alkane is methane, the next is ethane, following these root words here: methane, ethane, propane, butane, pentane, hexane, etc. So we are not going to prefix an alkane because it lacks a function. We are not going to use a locant on the alkane or a number between the ane because it lacks what we call the functional group in it there. So the IUPAC name generally should have the position which we are calling the locant can be 2. So we have prefix. If you have a name such as 2-chloro butene, as we are going to see, this stands for the locant. This is also a locant, the position number. Then this is called a prefix, the word before the root word. Then this is called the root word or the word root. Then this is called the suffix. So that's what the name should comprise of. Of course, in alkanes here, this one is missing because they don't have a functional group like the double bond. So it will just be butane if it's a butane. So let's start with alkanes here in the naming. So your name should have those characteristics. So have the first example here to name. So in naming organic compounds, remember we have to number the chain 1, 2, 3. We number from left to right and right to left. So we see this substituent or this branch is located at position 2. So we shall call it 2-chloro. Then the main chain, the longest chain has 1, 2, 3. So we check on this root word called prop. So, being that it has no functional group, shall call it propane. So this is the name. So let's check on this one. So let's check on that alkane there. So we first number the chain 1, 2, 3, 4, 5. Let's also number 1, 2, 3, 4, 5. Now, if we check the positions of the substance, this upper numbering gives 2 for this, and it gives 2 also for this because there are 2, so a 2 again. Then here it gives this one a 4. So this total gives us about 8. Let's check from down. Here it's at 2. Both of them are at position 4 when you use the lower numbering. So this total gives us 10. So the correct numbering would be that. And therefore, I'm going to name this compound as, using the upper numbering as 2, 2. So there is 2 for this and 2 for that. Then 4, then tri, because there are 3, trimethyl, a continuous name, trimethyl 1. So there are 5 carbon atoms. We use this pentane, trimethyl pentane. So that is the name for that one. Let's try to look at another one here. Maybe let's try to look into this, see how it takes us. Have it this way. So let's try to see if we number that chain there. So I have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we see that upper numbering will give this position 3. Then this one takes position 5. The total is 8 here. On summing this, you get 8. So look at down here, it gives position 3 and position 5 still. So the total is 8. Both are for that. So all the numberings are correct, but priority, since this is an ethyl group, we said in rule number 5 that for different substances in equivalent positions, then we give priority to the one that is named first. So priority goes to the ethyl group here. So the name is going to be position 3 is the one considered. So upper numbering is okay. 3 ethyl, then 5 methyl. The other chain is 7 carbon atoms. That one will take on the root word of hept. So heptane, no putting the locant between the root word and the suffix because it has no functional group. So that's for the alkanes. Let's now look at, in case we have an alkene. So in case we have alkenes, of course, the suffix in alkene is going to be ene. So I can have the first alkene here. So this is directly propene with this suffix here. We can't say prop 1 because even if I put it here, the alkene double bond will still be at position 1. So if you had such, then you'd number, and here position would be important because if you change this double bond here, it will be at position 1. So the first double bond, this is butene. Of course, now we are going to put the position between here. So we put it, the locant is between the root word and the suffix. So this is butene. Let's have such an arrangement. So several structures like that. Now, whenever you have a double bond and everywhere single bonds indicate alkanes. So priority goes to an alkene based on our priority table here, that alkenes come first in the priority table. So we would number from this side nearing the double bond so that the double bond receives the lowest term. the lowest locant. So if you had this, if you had such, then you'd better number from up, because the double bond first takes on a 2, then this can be mentioned last. So you can have it as our substituent is a methyl group, so 5-methyl. 5-methyl, since this is 6, to take on hex. But hexene, because it's an alkene, because said to maintain the alkene there, so that is hexene. Being that you have the double bond at position 2, we say the locant must be fixed before the suffix. So this is 5-methyl hex 2-ene. So let's dive into another example here. Let's have a structure having probably having kind of 2 double bonds in the structure. So what we do, we first write the double bonds, the positions rather. So write also below here, right to left. So we can check and see that the first double bond appears at 2 here, and the second double bond appears at 5 there. So let's check from down. The first double bond appears at 1 and appears at 4. So we see that the lower numbering is the most correct, keeping in mind that we are giving priority to the double bond. So here we are going to take this into action, but our branch is at position 4. So that is 4-methyl. 4-methyl, then 6 carbon atoms, that's hexene. But we must introduce a locant here before the suffix. So there are 2 locants at position 1 and 4. So 1, 4. Then because there are 2 alkenes, it will be diene. Now this name is not acceptable. This is hard to read at this point. If you look at this, you can't read the hex diene. So IUPAC recommends we introduce an A here whenever you have 1, 4, diene, whenever the suffix has a letter that cannot be read together with this. So we maintain this, we introduce in A there. So 4-methyl-hexa 1,4-diene, that's according to IUPAC. So let's have a case for alkynes here. So in alkynes, of course, the suffix in alkynes is YNE. YN is the suffix. So this being having 2 carbon atoms, the root word is eth. So eth with the suffix wine. So let's try to check on this. We try to check on this chain here. Now, always priority must be given to the priority must be always given. Let me adjust this chain to have some issues in it so that we can have it. So priority always is given to the alkene, because the rest of the structure is alkane or having single bonds. So we can try to number that 1, 2, 3, 4, 5, 6, 7. Down 1, 2, 3, 4, 5, 6, 7. So checking up here, the triple bond is at position 2, then the triple bond is at position 6. So down, the triple bond is at position 1, triple bond is at position 5. So total here would give 6, total here would give 8. So down, lower numbering is the most correct. So we are going to go with the lower numbering to give this first methyl group 3, then this is 4. So this is 3,4 dimethyl, 3,4 dimethyl. Then we are going to get our root word for 7 is hept. So hept, but because I'm going to use diwine two groups, I'm going to attach an A here according to IUPAC. Then I'll cater for their positions 1 and 5 here. So that one would be 1, 5. Di-wine. So that's the name for that alkene chain there. So I think that one could be enough under alkenes. Let's check on what we call the halogen alkyl halides here. So under alkyl halides, so those that have the halogens in them. So if we had such a structure, how would we name that? So of course we would first number the structure 1, 2, 3, then 1, 2, 3. The branches or the substrates are 2 and 3 up here. Then down the branches are at 1 and 2. So lower numbering is the most correct. So we are going to have 1 for this and 2 for this. So that's 1, 2 dibromo. Then the parent is going to be propane because it's going to be propane because there are 3 carbon atoms. So that is propane. Okay, let's try out this and see how it takes us here. Now let's try to number that carbon chain. So we are numbering from 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now by checking the upper numbering, the substrate bromine is at position 2 here. Then I have this at position 5. Then I have the ethyl group at position 4. But remember, we are going to name bromo first, ethyl next, then methyl next. So down, let's check down here. We are numbering the ethyl group at position 3. Then we are numbering the methyl at position 5. Then also this one at position 5. Up here we have position 2 for both, sorry. Up here, bromine is at position 2, methyl position 2, this position 4. Then down, this ethyl position 3, this position 5. So this total is higher, this total is lower. So the correct numbering would be the upper numbering there. So let's try to come up with the name. Bromo is first in alphabet, so 2 bromo. Then ethyl next, 4 ethyl, 2 bromo, 4 ethyl, 4 ethyl, then 2 methyl. Then our longest chain is a hexane, so it will be hexane. So that's how you name those. You follow alphabets for alkyl halides. Let's now check on the alcohols. Check on the alcohols. Now alcohols are named as alkanols. If we check in our principal name here, they are called alkanos. So our 2 carbon atoms, 1, 2, that will be ethanol now. Alkano, ethanol. So we can't prefix this functional group. We can't add the locant because this, even if we shifted here, the name still will be maintained. So let's check on this other example. So if you looked at this and this position here, now let's try to look at that. Of course, we have the alkane here in the chain single bonds. Then we have this. So priority goes to the OH. So we number from the OH there 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. OH is at 2 than 4. So we prioritize 2 than 4 because the principal group. So we shall give this position for this 4-methyl. 4-methyl, then that one will be alkano, being that there are 5, it's pentano, but IUPAC says that you must introduce a locant between that root word, then we can have it as pentan 2-ol. So that's why this one of course is propanol, but I have to introduce a locant, propan 1 there. Let's have another one here. Then we have also this structure here. Now we see that for this case we have 1 and 2. So this one is ethanol, but because there are 2, we shall call it eth. We shall prefix something here, position 1 and 2. Then because there are 2 diol, but IUPAC says that in case this is a consonant, if it's not a vowel, then we have to maintain the E here. Otherwise, we would drop the E like we drop propan 1 or like that. So for this case, 1, 2, 3, the OH groups are located everywhere. So that one will be propane now. 1, 2, 3 triol, because this is not a consonant. So we really have to introduce this here according to the IUPAC. So that's how we name the alcohols. Let's dive into carbonyl compounds here. Carbonyl compounds. Those carbonyl compounds, we say they are divided into alkanals, whose structure ends with a hydrogen, such as maybe let's have this. This is an alkyl group. So we can have this one ending here, and have another chain like this. Then finally have this structure there. So these ones are called alkanals. Of course, there are 2 types. We have alkanals, then we have alkanones. So this is the principal name, alkanon, alkanals. So this being 2 carbon atoms from al here, so this is ethanol. Then this one, of course, priority goes to this functional group, because alkanes and the halides here, halo atoms here, are actually ranked down in the priority table there, that we ranked them there. So priority goes to this 1, 2, 3, 4, 5. So I would have it named as so my chloro group, then methyl group. So this is 3 chloro, then 4 methyl. Then since there are 5 pentanal, we don't add the locant to this one, because this functional group is always at the end there. So that's how we do that for alkanol and alkanals. Let's look at alkanones also. Alkanones, for them, they are actually alkanones. They are actually containing the carbon atoms, such, let's have this illustrated. So they don't end with actually a hydrogen, but actually end with carbon on both sides here. So you have it as this one, alkanon, will be now propanon, from the alkane name, propanon. Now, in case we tried to increase the number of carbon atoms, like here we would have priority, of course, according to the priority table, we would give the ketone, which is the alkanon, best choice. So we number from this way, 1, 2, 3, 4, 5, because nearer this. So this will be acting as a substituent, and the substituent for the alcohol group or the OH group is the hydroxy. So this one is going to be 4-hydroxy. 4-hydroxy. Then, being that there are 5, that is pentanone. Pentanone. Now, because of this position of this functional group, we have to introduce a locant here, pentane 2-on. That's how we name those ones. Let's now dive into maybe Assuming you have two functional groups of that nature, maybe you have this again. So again, it is 1, 2, 3, 4 alkanone, that's butanone. But because there are two here, then we are going to introduce, there are two, but position 1, 2, 3, 4. So this is butane. We said this must be kept in butane 1, 2 di1. Butane 1, 2 di1. We said because this one and this one are important. This should be a vowel to be able to remove this. But if it's not, then this can be this. We maintain this E here. Now let's dive into what we call the carboxylic acids. So carboxylic acids have this representative formula. So we can have, they are called alkanoic acids. Alkanoic, so like this is the principal name, alkanoic acid. So if you have something like this, you call it ethanoic acid. Ethanoic acid. So if you had something like this, and maybe you have OH here, and you have something like this at the end of the chain, so still you would number from this way, being that the COOH is the priority group, so you'd have it as numbered in this one given first priority first, then you can choose others. So would give it the lowest digit, which is actually 1. So OH would be at position 3 and methyl at position 4. So this will be 3-hydroxy. The hydroxy group is H is first in alphabet than methyl, so 4-methyl. 4-methyl. Then this is pentanoic acid, being that there are 5. Pentanoic acid, we don't prefix that because this OH is located at the end here always. Let's discuss something on amines. Then we can give the general form, the general cases. Amines. Amines are of different types, but we shall only limit ourselves to the simple primary amines. Now, amines are named as alkanamine. Alkanamine with the suffix amine. If the amino group is a branch, then it's amino. So we can have this one as the first member. So this is, can name it as methanamine, or we can name it as methylamine or aminomethane. So any of those, they are really recommended, amino, methane, so any of those. Now if you had such a chain, of course you'd call it propylamine, or you'd call it propanamine, but when you use this kind of naming, then you should fix the position of the amino group. So this would be 1 amine there. If you add such, this one would be 2 amino. Propane also, these names appear in textbooks. Then this would be, we can call it propanamine, but prefixing this position 2 as propan 2 amine. So this is another name for naming that. So you can name it any of those. So that's how we name amines based on our principal name here. Let's now dive into mixture of these compounds. We combine them, and here we can choose priority over certain groups here. So we can mix up functional groups. So before you mix up functional groups, let's try to also learn to name our cyclic compounds first here. Then we shall have a mixture of functional groups there. Now, our cyclic compounds, you attach the word cyclo. For instance, if you are naming this, 5 carbon atoms, 1, 2, 3, 4, 5. So this is cyclo. Then you attach it to your root name, root word, pent, because there are 5. Pentane, since there is no another functional group there. Now, if you had something like this, then maybe you have something like this. Then say maybe you have something again like this. You have here maybe this. Now here you number like this. You don't number from here because you'll be skipping the key important or the most priority group here, the double bond. So this one would be at 3 methyl. Because if you number like 1 going this way, it would be at the largest position. So you'd better number from here like this, not this. If you had numbered the other was from here like this. So this is 3-methyl cyclohexene, but because this double bond is at position 1 in here, so you must include that position. Let's look at this. This one, this is ethyl group, and the methyl priority goes to this one. So this is 1, 2 priority because this is going to be named first. So this is 1-methyl. Then 3, 1-ethyl. Let's start with capital here, since we are starting the word methyl. 3 ethyl here. This is ethyl. 1-ethyl for this, 3-methyl. Then cyclo. This should be a continuous word here. Cyclopentane, this is continuous, no space. So this is cyclohex, hex 1 in. So that's how you name those. Let's try to name some other ones here and you see, in case, assuming you had such a thing. And you have this. So this acts as a branch. So you remember, if this is cyclohexane, but because a branch it will be cyclohexyl, like other branches like methyl. So this is 1, 2, 3. So 2 cyclohexyl. Then propane is the parent or the longest chain. So let's try to name this. We try this. This is now numbering, because we prioritize. In case the alkene was not here, was only here, we would give priority to that. So this is position 1. 1, if we counted this way, would still be at 1 and 3. This one is 1 and 3 still. So we consider just the upper numbering, that's all. So this will be 1 cyclopentyl. It's an alkyl group, pentyl. Then pentyl. Then the longest chain here, the parent, going to be 4 butene. Now, being butene, it has double bond here and here, double bond at 1 and 3. So we call it buta according to IUPAC, buta 1,3-diene, because this can't be read well with the T here. So let's dive into mixing those functional groups. So other examples here. So maybe assuming you have this structure with maybe the amino group, what would you select as the key functional group there? You have this with let's have some example here dealt with here. in this minor section here, then you have the CH2COO. So here we base, if we are looking at these functional groups, then key, let me put here another one here, minor group here. So emphasis would be which one do you make first priority? So from our priority group here, we see that the carboxyl group is taken priority with. So we number from it 1, 2, 3, 4, 5. Then this is 1, 2. Well, here priority is given to the carbonyl group because the amines come in later. 3, 4. So correct numbering is this. So the amine is at position 4 for amino. So this has a functional group having carbon to carbon here, and it's a ketone. It's an alkanones here. So we are going to call it having 4 is butanone. Butanone, but position 2 for the functional group here on. Now let's look at this. Still priority goes to this because it is the ranked first. So these are branches now. So our amino is first than hydroxyl, so I'll call it 3 amino. With capital here. 3 amino. Then 3 amino. Then 4 hydroxy. 5 of them pentanoic acid. Pentanoic acid. Assuming you have such a structure, such an arrangement. Now, if you had such a structure, priority between alkene and alkyne, we see that alkenes are prioritized than alkynes, so we number from this way. So 1, 2, 3, 4, 5. So this would be called, this is 5, pentene, keeping this as the key functional group, pentene, but because we have this at position 1, so it is pent 1 in, then I can't complete here because there is an extra functional group here, 3Y. So that's how we name that. Let's have a change of question, draw the structure of each. 2,2-dimethyl, butane, 1-ol. So let's check on how do you draw the structure. Now you first just look at the parent name here and first look at the carbon atoms. First draw it, the carbon atoms, their but is 4 from the root word. So it has an OH group all at position 1, so put it there. Then it has 2 methyl groups, both at position 2. So 1, 2 you name from the priority group, 1, 2. So methyl groups here. Then fit in hydrogen atoms. Then compress the structure because we don't want this. So I have it CH3. This one CH3, CH2. Then this one, it's partial compressive structure. So this is CH2 OH. Now, thank you for watching. I hope you found the video learning. Now, remember, if you have never subscribed, hit the subscribe button to receive more interesting videos. Let's meet in the next video. See you. Thank you.